All right. So, welcome back, folks. I hope you all had a good fall break. We're picking it right back up with lecture 3. This is kind of just a continuation of last time, so I hope you all will remember some of the database stuff. I want to keep it down. Thank you. So yeah, we're just gonna pretty much pick it up from where we left last time. Does this work? Yeah. Cool. So, fall break happened. So let's review a little bit just so we get you guys back up to speed. For those of you that remember, we have the client-server model, right? Where the client sends a request to the server. And the server does some stuff with that request, right? So we've been teaching you guys about these CRUD routers, right? Create, retrieve, update, delete. So it's going to trigger some sort of route. The server will then do some sort of processing, right? That's why we have a backend in the first place, to do some sort of operation on what we get sent. And then finally, it'll return a response, right? So that was what we did in lecture 1. In lecture 2, we went a little bit deeper on what that data operation is, and we were like, okay, guess what? There's a database now. I do want to point out that, like, not all backends need a database, right? It's kind of harder to think of one that doesn't, but the first example that always comes to mind for me is, say, Ithaca Transit. We don't have a database for transit, right? Because what happens is people will send us requests to be like, hey, this is where I am, this is where I want to go. We don't need to store who these people are or where they're going, right? We just need to do some processing to figure out what routes we should give them. So we do store some data. We store our route information, but we want that information to be processed faster than a database might do it. So we actually load all of that information just straight into memory. So that's an example of an app that doesn't need a database. But for most things, you're going to be able to think of database. Cool. So what do you do with the database? You do some sort of SQL command, and then the database does some sort of data for you, right? So we talked about that last lecture. That's your selects, that's your updates or inserts into update, delete, etc. Right? SQL has commands that kind of mimic a lot of those CRUD commands we talked about before. Cool. And so then after that, the server can finally return a response. Right? That's what we did last time. This is what I just said with green. Look at it turn green. Cool. We also focused mostly on the single table database last time, right? Which, one thing that I hope we did kind of emphasize to y'all, databases don't just have to be one table, right? They're easier when they're just one table, but if you want to have multiple things related to each other, say, call back to PA1, when we had comments and posts, you're probably going to want to store that in different tables, right? Think, again, to like Microsoft Excel or Google Sheets. You can have multiple sheets in each of those systems, right? You can think of each sheet like its own table. Yeah, whatever. This lecture is going to be on relational databases. So it's really going to be focusing on how we finally integrate these tables with each other, right? Because if we just have like multiple distinct tables that don't talk to each other at all, why do we have multiple tables and not just multiple databases? They're in the same database for a reason, right? So the main idea is we want this data to be able to interact with each other and know what's up. So, you know, in the comments and posts analogy, the comment needs to know which post is the comment of, and the post needs to know which comments are its own comments. Another example, you know, if you're Facebook and you want to know who your users are and what their relationships are to each other, you want to know who's friends with each other, you want to know who's blocked each other. If you're Instagram, you want to know who's blocked each other and not tell people who've blocked each other. Or, you know, Venmo needs to know like which transactions are done by who so that it can, you know, not send your money to someone suspicious. That's not who you intend to send it to. Cool. So one example is if you have this user table and a post table, right? Say you have some sort of like blog program or something. Or, you know, campus wide even. You have a user which, you know, for sake of simplicity of this slide, just has a name. Probably has some other data stored with it too. And then the posts are going to have whatever the content of the post is. Right? One easy way to relate these things to each other is through that third column, right? We've just added a column that maps from the post to the ID of the author. That's one easy way to do it. And that way you don't have to just mash all of this information together. You just say, okay, here's the ID. And then now that you have the ID, you can do a quick SQL lookup using select where ID equals whatever that spat out at you. And now you have Jane. that column that references the user table is called a foreign key. If you remember from the SQL syntax from last week, we have primary key in our database. This is a foreign key because it references another table, a foreign table. It's also called secondary key because it's not primary key. Yeah, not super complicated, right? It just says, here's the ID that this is referencing. The problem with this is there's a couple different kinds of relationships you could have. That's useful in this second example called a one-to-many, which we'll go over a little bit more. But there's a couple other kinds. There's a one-to-one relationship. There's a many-to-many relationship. So I'll kind of explain what each of those are in a bit, but I have it on slides, so let's start with one-to-one. One-to-one is pretty much what it sounds like. For every one thing in table A, you have exactly one thing in table B. Think of people and student IDs, right? Maybe you have some sort of table that's just dealing with, like, I don't know, like financial information of students. And you have some other table that's dealing with just like biographical information of students. For each student in the biographical information table, you better hope there's only one student with financial information tables, because otherwise we have some sort of weird financial fraud going on. So yeah, that's an example of one-to-one, because for every net ID there's only one student. Yeah, so in this example we have the user in the profile table. The profile table has the user ID column to reference whose user profile it is. This is really kind of up to design, right? You might ask, okay, hey, why is this column in the profile table? Because we wanted it to be. You could have it in one table, or two tables, or either table, but not neither table. Assuming you want there to be a relationship. If you really don't care that these things are related to each other, I guess you don't need it in either table. But. So yeah, now that you know which user ID it is, same as last time. You could just get the ID from the other table. This is what this looks like in SQL, which is kind of what I wanted to get to, right? So you come over and we say, hey, we have a new column for the user ID. We happen to be storing IDs as integers, and we want to enforce that it's unique, right? And so that essentially prevents the weird janky fraud from earlier, where we're like, hey, in this other row, we don't want to have another row that references the same student. That's problematic. Make sure that this is unique, and if I try adding a row that violates that property, yell at me. So it's just kind of a safety check with that. And then you'd also, because SQL is smart and it knows about these kinds of things, you have to tell it, foreign key user ID references user ID. The parentheses are kind of important. So this first one is the name of the variable, or the name of the column, sorry. And then references, the first thing is the name of the table, and the second thing in the inner parentheses is the name of the column it references in that table. So, you know, if we wanted, we could have called this column foo, and I really hope you're calling your ID column's ID, but if you're not, maybe it's called bar. And so in that case, it would be foreign key foo references user bar. I hope that makes sense. Do y'all have questions about the syntax? Coolio. And yeah, in the insert intos work the exact same way as they do before. When we want to insert into profile, we just say, hey, we're also adding to the user ID. Now we go to one-to-many relationships. And this feels like a relationship that's pretty intuitive to think about, but can trip people up sometimes. So this is the comment and post analogy, right? For each post, you have many, many, many comments, but like, for each comment, it's probably only associated with one post, unless you have this like very strange system of social media, right? This also works using the exact same method we've been talking about this whole class. You just stick an extra column in that table. But this time, you don't enforce that it's unique. So we can have multiple things referencing, right? So in this case, maybe we want to store albums and songs, right? Multiple songs are in an album. So, you know, let's say you're Spotify or something, it's easier to group things up by album. People can search by album, and then once you have the album, you can tell them what songs are in the album, right? So in this case, we know that we want Taylor Swift, and so we look into album ID 10 and we find some of our Taylor Swift songs, right? But what if we're Jack, and we want to watch Grease 2 and listen to Grease 2 songs? This is a reference to another lecture where I made fun of our 17-week for liking Grease 2. Grease 2 is a bad movie. But anyways, he really likes Grease 2. And so he maybe wants to listen to the Grease 2 album on repeat. And so he looks for Grease 2 and finds reproduction and Who's That Guy in our song table, which are both names of actual songs in Grease 2. So in this case, we have almost the exact same syntax as last time, except instead of unique, we have not null. Because we still have the column, but we're not enforcing that no other rows can have the same author ID, right? Or foreign key ID. Good there? What's up?
Does unique imply not null?
Yes. Cool. So in this case, we are adding, Jack is hacked into our database, and so he's adding another Grease 2 song, Who's That Guy, into our song table, right? And then all of a sudden, he's like, you know what, I want to find all the Grease 2 songs again. So he selects from song where the album ID is 20. Cool. Finally, there's the many-to-many relationship. And this one is going to be the doozy. Because we somehow want to make this structure where you can have a bunch of rows in some table refer to a bunch of other rows in another table. So, you know, imagine Twitter. On Twitter, a single post can have a bunch of hashtags, and then you can click on a hashtag, and all of a sudden you're looking at a bunch of posts, right? It's not like one post declares a hashtag, and all of a sudden it is the only post that has rights to that hashtag, right? As much as some people might want to believe that. So, the question is, how do you do something like that? We could try doing what we did last time, right? And say, what if we have just a bunch more columns to store all of the different relationships we have? That is problematic for various reasons. You can imagine it might cap maybe the number of hashtags you want to have in a post, or the number of posts you can have in a hashtag. Maybe you just have a single column and it stores a list. That's kind of weird because you don't want to iterate through all of that, and also it makes updating strange. And I'll go into all of this more in detail in a couple slides. It's just kind of an overview. And then 3 is what we're going to be doing. So it is left intentionally mysterious and called a join table. Moving on. So let's say we try going with the first example, right? So we have some student and course database. And so we have our student table and we have some kind of course table. Or, yeah. So what if this student wants to enroll in more than 3 courses, right? Oops, can't store that. Out of luck. Well, okay, what if we do the second method and we do lists, right? So we say, okay, in the student table, student 1 is enrolled in CS 1110 and then this course, 1998. And then in the course table, you also have references back to the student, right? And this time you do need the cross-references. So the course CS 1110 is referencing both of the students because they're both enrolled in 1110, but only the first two. Yeah, this slide is wrong. The 1 and 2 should be in the second row. I can count. We're thriving. But anyways, let's say you wanted to find the courses that student 1 was in. You would say, okay, it's in 1110 and 1998, and then you select that from the course table. Seems fine so far. And then you want to see which students are in 1110. And so you're like, okay, it's 1 and 2, so it's both of these students. Cool, that's working out. But now let's say we add a new student into both of the classes. All of a sudden, we have this mismatch in the course table, right? And now we have to go back and update the course table for every single class that this student has enrolled in. That's just kind of a lot of write operations, right? And you can imagine now that if we're storing things as a list, maybe we're deleting students from the middle of the list, right? Or, we added the student, now let's delete the student. And all of a sudden we have to delete them from the course table again, which is just a lot of effort. See, there's the 3 left, and now we have to get rid of that. So this is the solution. The join table. And the idea is, hey, we know that we want to reference many of these things together. What if we just made our lives as simple as we possibly could? Make a new table, and each row in that table represents a single relationship. So, in this case, we have a join table of students and course IDs. So each row is 1 student and 1 course. Now all we do is we add as many rows as we want. So if a student is in 7 courses, that means we have 7 rows, each with the same student ID and different course IDs. And if you have, 30 students in a course, we have 30 rows with the same course ID and different students. Simplifies things. And now, when we want to translate from the student to the course, we just say, okay, let's get the student ID, in this case it's 1. Go to our join table to ask it, hey, what's the course ID associated with the student? And it says, okay, they're in 1110 and 1998. We're like, cool. And then we can select both of those from the course table. So it does add a kind of middleman, but it makes updating a lot easier. Because now we're only dealing with one table in the middle, not any of this weird write to 2 different tables every time you do an update. Yeah, no, students in CS 1110 works the same way backwards. Cool. Yeah, and now, student 2 can enroll in 1998 super easily. You just add one more row into the join table. The syntax for this is fairly what it sounds like, right? You have your student and course table, which are the same as they were before, and now you just have one more new table, which has 2 columns, the course ID and the student ID, and then 2 foreign keys, right? Because they're both foreign keys. You might wonder why we have to specify foreign key, because hey, if we can just get this course ID and student ID anyways, we can just do a select using that information, right? SQL has this fun inbuilt thing called a join that we're not going to go too deep into in this class. If we have time, Gonzalo might cover it in the demo. But it will helpfully join these tables for us using what we've defined as foreign keys. That's the reason we have to define it. Cool, I guess that's the end of the lecture. Any questions before we move on to the one thing before the demo? I have a Kahoot today.
Oh.
Okay.
Can I join?
No. Okay, so if I go here, and I think it's,
I don't think I'm going to do it.
maybe it's this. Hey, that looks like it's recording. Okay. Join the Kahoot without inappropriate names. What's up?
This display capture is cropped for some reason. I'm not sure why. How did you...
I just didn't check. Oh, thanks. I love me too.
What about when I switch to VS Code? I love Rocky, I love good.
Oh, there's an I Love Gonzalo too. Well, there's 2 I Love Gonzalos. I'm losing. Someone's Greece too, and
Hey,
they're just
what
wrong.
about me?
Yeah, we have Taylor Swift. Yeah, let's not go for that one. Dang, y'all are meme lords. Cool.
Oh.
That is like a valid opinion to have because it's not like the original Grease is that good, but it still feels wrong. Rizzo was a really good character in Grease.
Wow, no one loves me. This is a sad day for me.
All right.
The Bronco.
I'll give you all like another minute. I love baseball, boy. For those of you all that don't know, Shungo plays baseball.
Wow.
What a cool kid.
That's so cool.
All right. I'm going to start in like 5 seconds. 3, 2. Let's go.
2.
I can count, okay? Look, man, don't judge my Kahoot. What do we call the column that distinguishes a relationship?
Divorce.
Look, all of these questions originally had 3 answers. I didn't know what to put in the 4th one.
Where the Kahoot bulbs at though? Yeah, where's the English?
True.
Where the Kahoot?
I don't know. Cool.
No one
Yeah, relationship column would be kind of a good name, but it's called a foreign key column because it's a foreign key to a different table. And then ID column, that's the main column in the table, right? So if in your post table, the ID column is like the main ID, and then the foreign key column is what references another table. Gonzalo's not a real person. How was Greece 2 in second? Okay. Y'all have 4 questions left to beat Greece 2. That's the only thing I'm caring about here. Nah, man. What type of relationship would you use between Venmo users and transactions?
I like these fourth options.
Thank you. I had fun coming up with them. Cool. Ooh. Yeah, this is kind of a trick, right? Because the transactions could be considered the join table between users, right? So it would be a many-to-many relationship between users hosted in the transactions. That one was a hard one. My hopes and dreams have been trashed. It's okay, I'll have 3 more questions, come on. I said this one in lecture. Did I turn the mic off? Oh no, it fell. It fell. Yes? Post and comment.
I love post and comment.
Nice. This is such an even one. I like how there was like 1 for each of the answers. Cool. You all seem pretty good at that one.
Oh my
Yo,
God.
both of the I Love Gonzalo's are on the leaderboard. 4th question. Which is best for a 1-to-1? Nice.
Oh my.
Cool, cool. Final question. Which example is best for a many-to-many? It's green.
There's 2 I love them.
I'm so glad it didn't like switch around the colors because it does that sometimes, and like that would have made that make no sense.
There's 2 good
Nice.
I love Gonzalo's in my leaderboard.
Like I guess a credit card could be with multiple people. I think that's a thing that can happen, but I think each credit card has 1 name on it. Cool. Four out of 5. Greece 2 was dethroned. Let's go. Oh wait, no, this is 3rd place. It counts the other direction. You should feel bad. My life is in shambles. What have you done to me? All right, well, that was lecture. I hope you enjoyed it. Cool. Stop recording.
Okay, everyone in the back can hear me? Good. Great. All right. I'm going to start off by doing some of the SQL in SQLite.
Make your terminal bigger.
Yes. Okay. I think this should be big enough. How's that? Great. Okay. So, we went over 3 different kind of relationships. We went over 1-to-1, 1-to-many, and many-to-many. So we're going to go in that order. The tables I'm going to be creating are going to be modeling CampusWire. So in CampusWire, we have students, and each student has a profile. So that is a 1-to-1 relationship. So let's make those tables first. I'll create a table called student, and then we want each model to have an ID, as always. This is an integer primary key. Each student has a name, which is text and is not null. And that's about it for a student. So that compiles. That was a mistake. Okay, I'm gonna do this again because I put a comma. And we're good. Okay, so if I do dot tables, I have my student table. And let's insert some students in here. I'm going to insert into student. Let's insert a name. I'll insert myself. And let's check to see if I'm in there. Perfect. I'll also insert Rahi. And let's try one more time. Perfect. Okay, so now we have a student table. Let's make a profile table. So let's make another table called profile. This one also needs an ID. And for your profile, you have a status, which tells you if you're online or away. This will be text, and this should not be null. And what else should be in the profile? Okay, well, this is a one-to-one relationship. So each profile has a user associated to it. So you need to also put the user ID. And this is an integer that is not null. Or, well, it should be unique because this is a one-to-one. We don't want a profile to be associated to two different kinds of users. We want it to be associated to one. So this should be a unique ID. And then we also want to make it a foreign key. So type in foreign key. You want to type in user ID. And this references from the student table, its ID. And let's see if that works out. So let's check to see if profile was created, and let's select from profile, it is empty. So let's make a profile for myself. So I'm going to insert into profile. Let's insert a status. And then I also need to insert a user ID to associate it to me. So I'll include that inside of this parentheses. And then let's say I am online. And for the user ID, I have a user ID of 1, so that's the one we're going to insert. So let's check inside of profile to see if that worked, and it did. This ID is the ID for the profile table, and this is the one referring to the user ID. We'll do the same thing for Rahi. So this one's going to be away, and then this will be 2 for Rahi. So if I check profile again, I now have my status and Rahi's status. So let's say I want to insert Rahi again, but let's say he's online now. If I do that, I'm going to get an error because you can't insert 2 entries into this table with the same user ID because of the unique constraint that we put. There's one little tidbit with SQLite though. If I were to try to add online status for a user that doesn't exist, it will work. So you need to be aware of that when you're doing the assignment and in general. This happens with SQLite. Other SQL frameworks might not do this. It might prevent you from doing this. So this is essentially how you do a one-to-one table. So now we have users that are associated to profiles. Now let's try to make a one-to-many relationship. So if we're doing Campus Wire, every student can post a post, and there can be many posts associated to a student. 2 students can't have the same post, so this is one-to-many. So let's make a table called post. This has to have an ID. And every post has a description associated with it. We'll say that every post needs to have some kind of text in it. And we also want to associate a post to a user. So in this case, we're going to do as we did before, but now we don't want it to be unique, because if this were unique, that means every user can only have 1 post. That would be one-to-one. We want users to be able to make multiple posts. So we'll say that this is not null. And then as before, we can just associate this. I'll say that the user ID references the student table's ID entry. So let's make a post for me. Say insert into posts. I want a description and I want my user ID. Let's say I just did the assignment. I did assignment 1, I really liked it, so I just post I love backend. And this is my user ID. So let's check that. If I were to select everything from post, there it is. Now let's try to add something from me again. I did project 2 and I had a bad time, so now I hate backend. And if I were to select from post again, you'll see that there are 2 entries under my user ID. And that's how you make a one-to-many relationship. Any questions so far? Cool. If you're having any issues, you can raise your hand and we can help you out. So now we have one-to-one, we have one-to-many, and now we want to make a many-to-many relationship. So on Campus Wire, you are currently enrolled, hopefully, into our backend course. And you can also enroll into courses from other professors. And so since a student can be in multiple courses and courses can have multiple students, that is a many-to-many relationship. So since we already have the students table, let's make a courses table. So we're going to create one more table called courses. And it has an ID, as all tables do. We want to have the name of the course. Say it has to have some kind of character in it. And that's about it. Simple as that. And let's insert 2 courses. I will put this course, CS 1998. And let's put in one more. We'll put in Java 2110. Let's check courses. And they're there. So I want to associate a student to a course. If you remember from the lecture, we used a join table. So this table is going to have IDs of students mapping to IDs of courses. So we need to make our last table. We can call this table enrollment. And in this table, again, we need to have an ID for each entry. We need to also have an ID for the student. So I would just consistently use user ID. This should be not null because a student may be in many courses. We also want a course ID, which is also not null because a course can have many students. And then we want to make references for each of them. So for the user ID, we want this to reference the student table's ID entry. And for the course ID, we want that to reference the course table's ID entry. So now let's try to enroll myself into Java, and I will enroll Rahi into backend. So just as a refresher, oh wait, I think it is called student. So my ID is 1, Rahi's is 2, and if we look in the courses, it's not course. What is it? Is it not course? It's courses. Okay, wait. It will probably be problematic. Okay. I'm going to remake this table. Let's delete. Drop table enrollment. Okay, let's create this table one more time. Create table enrollment. It's very annoying with SQLite. User ID integer not null. Course ID integer not null. Foreign key user ID references. This is the student table. And then we want the course ID referencing the courses table. Cool, okay. Hopefully that works. All right, so I want to enroll myself into Java, and I want to enroll Rahi into backend. So I want to insert into the enrollment table. we want to enroll a user ID and a course ID. So if I wanted to enroll Rahi, or if I want to enroll myself into Java, I'm user ID 1 and Java's user ID, course ID is 2. And then if I want to enroll Rahi into Backend, his user ID is 2 and Backend's course ID is 1. So if I were to select everything from enrollment, it's there, but this looks pretty cryptic. So remember that it's called a join table, and the reason for that is because I can perform a join operation in order to make this look more readable. And it gives me relevant information because the IDs help me select things from tables, but ideally I want to get information from tables. You can explore joins more in the second extra credit. I can just perform one here to show you how it would look like. So if I wanted to, we can start off by saying I want to select everything from, I believe it is user. Yes. So I want to select everything from user, and I want to join. So the way a join works is I want to start from an ID. I need to go to another ID. And with the enrollment, remember that I want to go from the user ID to the user ID in the enrollment table. And then I look at the course ID, and then I can find the course in the courses table. So what that looks like is I want to join enrollment. I think it's join on the user ID equaling enrollment dot user ID. And now I want to join the courses, that's the name of the table, on the enrollment's course ID and the courses ID. Hopefully this works. You know, okay, okay, yes. Student. This should also be student. And yes, perfect, okay. So you'll see that this got information from the student table, the enrollment table, and the courses table. This is a whole big mess. So if I want to specify what exactly I want, instead of getting everything with the asterisk, what I can do is all I care about is I want to know what student I have and what course they're in. So I can do that by getting from the student table the name, and I can get from the course table that name. And then if I were to just get the previous commands, oh boy, course's name. Yes, you want to keep everything in the same plurality. Perfect, okay, so that's how that would look like. So that's what a join is, and that's why it's called a join table. You can explore more in the second extra credit. But enough of that, let's go into the actual Python code. So let's leave here. So I'm already in the starter, and we can make this a little bit smaller. So in the starter, I have an app.py and a db.py just like before. Remember, I want to make a virtual environment. I want Python 3. I want to activate the virtual environment. So I do .them/bin/activate. And then I want to download everything from the requirements.txt. So install requirements.txt. That'll give me everything, and then I'm ready to begin. So you can open this in your preferred code editor. I'll open this in VS Code. And before we begin, there are some outdated things in this code. So let's just take a quick look. This is actually the API that we used last semester. And I'll give you some intuition as to why we changed. So if you've been watching the old lectures, you'll see some discrepancies. Specifically, you'll see that there is a success field. There's success equal to true for success responses and success equal to false for failure responses. So the way we've been doing things in this class is we don't need a success and a data field. We just need to pass in the body. You can replace this with body. I don't care about this. This is just the body. And then for the error, I don't care about the success, I just care about the error. The reason we don't need a success field is because you can already infer that information from the status code. So remember that 200 usually means success, and for 400, that is a failure. All right, great. So what we're going to be doing is, if you look at the code base, it's essentially what we had last lecture with tasks. And what we want to do is we want to make a one-to-many relationship with subtasks. So every task has many subtasks, but every subtask belongs to one task. So we're using a one-to-many relationship. So let's just come up with some routes that we want to use. So with our subtasks, we want to be able to get every subtask. So get all subtasks. We also want to be able to get a subtask given a task. So we want to get subtask from task. And then we also want to be able to get a subtask given its ID. So get subtask from ID. So what would these routes look like? Forgetting. Oh, there's 5 minutes left. Do you think we need the coding part? Because we have to do code and see, like, is there anything like super new in the coding part of this? Not really. Because I feel like all these stuff, we don't need to go over time. Up to you. I know we're gonna go over time. Yeah, that's the problem. Yeah, that's the issue. There's not really anything. Okay, surprise. There is no more lecture. So what we're going to do is you don't need to really worry about this. There's nothing really new. If you're trying to get all the subtasks, it's essentially going to be how you get all the tasks. If you're trying to get a subtask from an ID, that's how you do your retrieval. I wasn't going to go over the updating or the inserting because it's essentially the same. The only thing that's a little bit different is how am I going to get a subtask given a task? All you would need to do is you just need to get the task, you want to get its ID, and with its ID, you want to be able to get the subtask. Because remember that each subtask is going to have the ID of the task ID, as in one-to-many relationships. It should be very similar to the second project. I will make a campus wire post to actually give you an intuition on how you would do get subtask from task. But yeah, we are almost at time, so I didn't want to actually go over time. If you have any questions, you can go up. Thank you.
Thank y'all for coming.